Welcome back to 3 Inquisitive Kids. This is part 2 of our lesson 3 in chapter 11, Perpendicular Bisectors. Again, here's our course outline for chapter 11. This is actually our 4th video in this entire unit, and we are going to be learning about perpendicular bisectors. Our learning goals for today is to understand the concept and properties of perpendicular bisectors, and be able to use the properties of perpendicular bisectors to solve problems. Here's some review. What kind of figures are considered axisymmetric? Well, if you fold a figure in half along a straight line and both parts completely overlap, the figure would be axisymmetric, and the line would be its axis of symmetry. Which of the following figures are axisymmetric? So the two images on the left and the two images on the right are all axisymmetric figures. The ones in the middle are not axisymmetric. You can see we have this butterfly, its axis of symmetry right down the middle. And this is a building in China, I believe, and this is where they held the Olympics. And as you can see, this is a reflection on the lake. And this is kind of a face mask that people paint their faces to look like when they are acting in a play. And again, this is a snowflake. This snowflake has more than just one axis of symmetry. Is the line segment an axisymmetric figure? If yes, can you find its axes of symmetry? What is the relationship between the axis of symmetry and the line segment? Here we have line segment AB. We can try to find its axis of symmetry right down the middle like this. And you might be thinking, well, why can't we do it horizontally? Also, it still has a little bit of width, right? Well, the answer is no. A line segment is an abstract figure, and it's only supposed to have a length. It's not supposed to have a width. I want you to think about the relationship between the axis of symmetry and the line segment itself throughout the rest of this lesson. Maybe at the end of this class, we will be able to answer this question. Think about it. What is the relationship between positions of CO and AB? Are AO and BO equal? What about CA and CB? And I want you to mark another point on CO and see if the conclusions above are still true. Here we have CO, it seems like it's its axis of symmetry, and AB. You can also see that after connecting CA and CB, we're resulting in a isosceles triangle, and that's what we learned about in the last lesson. So CO and AB are perpendicular to each other, and AO equals BO. CA is therefore also equal to CB. And if you mark another point, let's say point D here on this triangle, and you connect AD and DB, we have another isosceles triangle, and AD would equal DB. The axis of symmetry of a line segment passes through the midpoint of the line segment and is perpendicular to the line segment. Any point on the axis of symmetry of a line segment has the same distance to both ends of the line segment. So, of course, the axis of symmetry has to split a line segment in half, or else it won't be symmetric, and it has to be perpendicular to the line segment. And any point on the axis of symmetry has the same distance to both ends of the line segment. So it doesn't matter where you are on this axis of symmetry, when you connect it with the two ends of this line segment, the distance will always be the same. And so this is what we're going to be learning about today, perpendicular bisectors. A line that is perpendicular to a line segment and bisects the line segment is called the perpendicular bisector of the line segment. The distance between any point on the perpendicular bisector and the two endpoints of the line segment is equal. And the axis of symmetry of a line segment is the perpendicular bisector of the line segment. So perpendicular means, of course, perpendicular, and bisector means splitting something in half. So if a line segment has an axis of symmetry, that's its perpendicular bisector. Here's some practice. Using a compass, so a mathematical tool, draw the perpendicular bisector of the line segment AB. We are given line segment AB, and we want to find the perpendicular bisector of AB. I want you to pause the video, and if you can, take out your compass and try it out on a piece of paper. Here's the solution. You first center the compass at points A and B, and then you draw an arc with a radius greater than half of AB. The two arcs should intersect at points C and D. So points C, points D. So this point and this point. And connect straight line CD. You can connect them together. CD would be the perpendicular bisector of line segment AB. When you are drawing all of these arcs, you have to keep the radius of the compass the same. As shown in the figure, DE is a perpendicular bisector of AC. Let's mark that out here. AB equals 12 centimeters. AB equals 12. BC equals 10 centimeters. The perimeter of triangle BCD is blank. I want you to pause the video and think about it for a moment. According to the properties of perpendicular bisectors, CD would equal AD, and therefore the perimeter of triangle BCD is BD plus DC plus BC, which equals AD plus BD plus BC, because AD equals DC. So we can switch them in and out together, which equals AB plus BC, which equals 12 plus 10, which equals 22 centimeters. Our answer would be A. Expand your thinking. A, B, and C each represent 3 different factories. A water supply station needs to be built so that its distance to each of the factory is equal. Mark the location, P, of the water supply station, and then explain your reasoning. This problem might be slightly harder because, after all, it's an expand your thinking problem. Here's a hint. First, connect AB and AC. Connect AB and AC. Draw the perpendicular bisectors of AB and AC. So this would be about here, this would be about here. The two lines should intersect at one point, which is point P. Perpendicular bisectors. Today, there's only one main point we learned about perpendicular bisectors. So any point on the perpendicular bisector of a line segment is the same distance from both endpoints of the line segment. I hope you enjoyed this video, and be sure to come back for more.